Hi, and welcome to the Worldwide Center of Math's Problem of the Week. This week, the problem is solve the integral of x plus 5 over x squared minus 2x minus 3. So this is not a definite integral, but we don't really know how to solve it to start off, so we can go through kind of the different ways of solving different integrals and integrating. So first off is just straight integration, and it's a little too complicated for that with the x squared as a denominator and it being a fraction. So then we can move on to u substitution, but if you set x squared minus 2x minus 3 as the u, you'll notice that du, the differentiation of u, doesn't actually work with this problem. You would get 2x minus 2, and that's not equal to x plus 5. So then we can move on to by parts, and this integral is not the product of two functions, so we can't use by parts. So then we move on to the last and final way of solving integrals, which is by partial fractions. So since we're going to be using partial fractions, the first thing that we can do is simplify the fraction as a whole. So taking x plus 5 over x squared minus 2x minus 3, what you'll notice is that we can actually factor the denominator into x plus 1 times x minus 3. So now that we've kind of simplified and created a factorized denominator, we can begin to use the partial fraction method. So to begin, we can see that for each of these factors, we need some constant over each factor. So we have a over x plus 1 and b over x minus 3. So now that we have this kind of equation, what we can do is simplify and then solve for what a and b are equal to, and then substitute in this whole term with what we find a and b being equal to and integrate that. It'll make the integration a lot easier. So to begin, we're just going to multiply by the common factors of both of these terms, which is obviously x plus 1 times x minus 3. So multiplying both sides by x plus 1 times x minus 3, obviously we can cross out the denominator on this side, and then we cross out each factor on each fraction. So we get a times x minus 3 and b times x plus 1. And on this side we have x plus 5. So now we can solve for what a and b are equal to by just plugging in different numbers for x. So starting, if we have x equal to 3, you'll notice that this will make this term 0. So that way we can solve for b. And what we get is a is equal to 4b. So we know b must equal 2. If we have x equal to negative 1, it'll make this term go to 0, and we can solve for a. And what we get is that 4 is equal to negative 4a. So we know a must equal negative 1. So now that we've solved for what a and b are equal to, what we can do is plug them back in here and turn this into an integral in itself. So plugging in what we've solved for a and b, we get that the integral of x plus 5 over x squared minus 2x minus 3 is actually equal to the integral of negative 1 over x plus 1 plus 2 over x minus 3. And it's pretty common with using the partial fraction method to get either the natural log terms or tangent inverse terms when you're integrating. And you'll notice here that if we simplify a little bit, we're actually going to get two natural log terms. So pulling out the constants negative 1 and 2, what you'll see is that this term is the natural log of x plus 1 when we take its integral, and that this term is the natural log of x minus 3. So solving, what we get is that that negative 1 times the natural log of x plus 1 plus 2 times the natural log of x minus 3. And since this is not a definite integral, we add in plus c for the constant. So that's all we have for you today for this week's problem of the week. I hope you enjoyed watching it. Please check out some more of our videos on YouTube. Check us out on Facebook and follow us on Twitter. Thank you.